Title of the first section is Find the Sum of a Geometric Series. Two equations or two formulas for the section. S sub n, or the sum of n terms. First equation is a sub 1, and inside parentheses 1 minus r to the exponent of n divided by 1 minus r. Second equation, or second formula, S sub n, so again the sum of n terms, could also be a sub 1 minus a sub n times r divided by 1 minus r. Like the arithmetic series, there's two different formulas to find the sum, or S sub n. You can use either formula depending on the information that you're given. The first formula has n, the number of terms, and the second formula has a sub n, which would be the last term. First question, we have a sub 1 equals 2, r is equal to 3, and n is equal to 6. Looking at the three variables given, a sub 1, r, and n, we'll be using the first equation. So to solve for s sub n is equal to 6, so we'll be looking for the sum of 6 terms. A sub 1 would be 2, 1 minus r to the n exponent would be 1 minus 3 to the 6th power, divided by 1 minus r, which would be 1 minus 3. Solving this, 3 to the 6th power would be 729, and 1 minus 3 would be negative 2. 1 minus 729 would be negative 728. 2 divided by 2 would cancel out, and we're left with negative 728 divided by negative, which would equal positive 728. So the sum of the 6 terms for this geometric series would be 728. Second question, and last question for the section. A sub 1 equals 12. A sub 5 equals 972. And r is equal to negative 3. Again, looking at the three variables given, a sub 1 the first term, a sub 5, which is the last term, and r equals negative 3, we'll use the second sum formula that was listed. S sub n, which n would be 5, so we're looking for the sum of the first 5 terms. A sub 1 would be 12, minus a sub n, which is the same as a sub 5, would be 972, and times the rate r, which is negative 3, divided by 1 minus r, which would be 1 minus negative 3. Solving, we'd have 12, negative 972 times a negative 3 would be positive 2,916, and 1 minus a negative 3 would be 1 plus 3, which would be 4. 12 plus 2,916 would be 2,928 divided by 4, which would be 732. S sub 5, or the sum of the first 5 terms, would be 732. title of the next section of notes is Find the Sum. Using a sequence. First problem, or first sequence, is 4096 minus 512 plus 64 minus ... as the sequence continues on. And we want to find the sum to 5 terms. So the first 3 numbers are given. We want to find the sum of the 5 terms for the sequence. Using the same formulas we just did, we can find A1, which is the first term. First term is the first number in the sequence, 4096. To find the rate for a geometric sequence, we'll take the second number divided by the first number, which is negative 512 divided by 4096. If we change that to a decimal, it comes out to 0.125. And the number of terms that we want to sum would be 5. Using the first formula that we did in the previous section, we'd have the sum of 5 terms, or S sub 5, equals A1, which is 4096, in parentheses 1 minus R, which is 0.125, to the n power, which would be 5, divided by 1 minus R, which is 1 minus 0.125. Solving this out, the sum of 5 terms, 4096, 0.125 to the 5th power, and this is actually a negative rate. 0.125 to the 5th power would be 0.4 zeros and a 3. And this would be negative since it's to the 5th power. Minusing a negative would be positive. 0.4 zeros and a 3. Divided by, and again this would be a negative in the denominator, so we'll be adding 1.125. Simplifying further, the sum of 5 terms, 4096, 1.0003 divided by 1.125. Using a calculator to multiply and then divide, the final answer would be 3,641. So the sum of the first 5 terms would be 3,641. Second question and last question for this section. We have the sigma notation. N starts at 1 and goes up to 9. And the equation is 5 times 2 to the exponent of n minus 1. For this problem, the formula is in geometric form, where we have a times 1, or a1 times n to the n minus 1 power. To find a1, the first term, again we can plug a 1 into the equation. 1 minus 1 would be 0. 2 to the 0 power would cancel out or equal 1, so our first term would be 5. To find the rate, again this formula is in the geometric form, a1 times r to the n minus 1 power, so r would equal 2. and the number of terms that we're looking for from 1 through 9 would be 9 terms. Plugging these numbers into the formula, S sub 9 for 9 terms would be A1, which is 5, in parentheses, 1 minus R would be 2, and to the n power, which would be 9, divided by 1 minus R, which would be 1 minus 2. Solving this out, 2 to the 9th power would be 512, and 1 minus 512 would be negative 511, divided by 1 minus 2, which would be negative 1. Multiplying 5 times 511, that would be 2,555, and we'll have a negative divided by negative, which will give us a positive 2,555 for the sum of 9 terms. Last section today is called Find the First Term. Using a sum. First question and only question for this section. S sub n equals 165. A sub n equals 48, and R is equal to negative 2/3. Using the sum, the last term, and the rate, we can use the second formula that we did in the previous section and find what A sub 1 would be. S sub n, or the sum, would be 165, equals A sub 1, which is what we're looking for, minus A sub n, which is 48, times the rate, which is negative 2/3, divided by 1 minus R, which would be 1 minus a negative 2/3. Solving a single variable equation, we can isolate A1 and solve for the first term. 165 would stay the same. A sub 1 minus 48 times 2 would be 96. 96 divided by 3 would be 32. And we also have a negative times a negative, which would be a positive 32. Divided by 1 minus a negative 2/3. Minus a negative 2/3 would be adding 2/3. 1 plus 2/3 would be 1 2/3, or 5/3, 5 over 3. Solving from here, instead of dividing by 5/3, we can get rid of that by multiplying by 5/3 on both sides. 165 times 5 divided by 3 would be 275, equals A1 plus 32, and last step, subtract 32, and we have A1, the first term, is equal to 243.